Now we got Max here, what's this? This is like your third DConf talk, isn't it?
Yes.
Third?
So
Third.
I'm going to rock the microphone.
Yes, that's what we like to hear. Max, rock the microphone.
Right. So I am going to talk about build systems because anyone who I've spoken at about this will learn that I'm quite interested in this one because it's new. Build systems are like aphorisms about opinions, and everyone has one. They're like recursive aphorisms about opinions, and everyone has lots of them. What everyone here, I assume, knows, we can automate processes with them, we can capture information about our builds and so on. They're very useful. We have lots of them, e.g. Make, but also Excel. Excel is a build system. They're all subtly different. So, for example, like Ninja and Make have different semantics, but kind of look quite similar. Without going into that too much, there's a very, very good paper called Build Systems a la carte, where they effectively build lots of different build systems in using snippets of Haskell, for example, because it's written by that kind of programmer. So, for example, like the way that they can express like the difference between the way that the things you need to do to deal with like dynamic dependencies, for example, monadically and so on. And the point that I want to get at is actually not so much about building things as much as I think the tools that we have both as an industry outside of basically a few kind of concentrated places where people spend money on this kind of thing are quite poor. So, for example, throughout every DConf basically, there's always a lot of like, how can we make the horse faster? E.g., we have like dub, redub, reggae, and so on. There's people using Meson and things like this. And they're all hobbled by various things. So, for example, like dub, as far as I'm aware, historically was trying to copy NPM or something like that along those lines. So anything downstream of it, reggae and so on, can only extract so much. You can only extract so much blood from the stone, if any. And I think there's an analogy to be made with testing in that you can view a set of tests about it. You just prove the absence of a bug, you fix a bug, you had a test, and so on. But more generally, there are a collection of assumptions you can make about a program, which is why we go to very long lengths to test things. And sometimes you put a lot of effort into, for example, to be like testing what happens if like a file operation fails, for example, is quite annoying, but it's worth doing sometimes. And I'd argue that our build systems don't capture enough information about what we're doing. Common problems occur quite a lot in software where pretty much regardless of language and even like choice of tooling a lot of the time, you end up with things that are slow, complicated, and brittle, and so on. If anyone's ever worked on a project that, for example, that has a script that you have to run, which like mutates your machine first so you can actually build the code, for example, I think a lot of the stuff is basically terrible. And one thing that Peter Thiel likes to point out is that in the kind of modern world, there's been a lot of progress in the kind of the bits, immense progress in software, but not much in like atoms. So, for example, you have a very modern software and so on, but the actual world you live in, with the exception of basically your phone, you might be, for example, if you went on the tube today, you'll notice that some of the tunnels are like 150 years old and the things don't work anymore. And I think this is sort of fractally true inside software, where like the code for the most part is actually probably better than ever in many ways, but the plumbing around it hasn't actually been that much progress. And in some ways, we've actually gone backwards. If you imagine like sitting down and writing out a make file for a project will often get you a more pleasant experience sometimes than using dub and so on, kind of controversially. These are kind of the thoughts that I'm kind of pinning on the door, if you will, where we've simultaneously ventured too far away from the sort of spirits you get in a kind of old-fashioned make file, and that there's a benefit to being forced to write things down explicitly. It's a sort of hormetic effect where the a little bit of pain is good for you, or radiation, depending on who you ask. But then we can't just go and use make files, for example, on a big project because they're still far too permissive, and also like no one has time to actually sit down and write them. And I think there's a solution in the form of that people have thrown money at this before, both kind of metaphorically and they kind of just throw money at the problem and also make it go away, but also because it's proven to be profitable in terms of developer productivity, like easily provable, for example. So like Facebook's what this talks about, this build system is probably the product of like tens of millions of investment at least by Facebook, and it's paid for itself, or at least they say it's paid for itself. Based on their like internal metrics of the throughput they get from the developers and the feedback loops and so on. The solutions that people have come up with, they all fit within a so-called like declarative build systems, of which there are basically a handful. They all have roots going back to Blaze inside Google, if I'm not mistaken. They wrote Blaze inside Google. People leave Google. They want Blaze elsewhere. So they ran away and then wrote Buck at Facebook. And I believe Pants at Twitter. And then Google open sourced, I think, which is sort of, it's bits of Blaze, but also it's own thing in the form of Bazel, which is probably the most mature offering in open source world, because Facebook threw Buck away and made Buck2 as of last year or something along those lines. In brief, Bazel and Buck both share the language you specify your builds in. They actually share, called Starlark, and you write things like this, and then you build stuff. It's not particularly shocking. Where things start to become interesting is that you can, for example, have the tests and documentation generation and so on encoded within the build implicitly as part of the declaration, thus the declarative moniker. Buck actually already has if you run it now, it does actually have a D binary, but it's technically a stub, so it doesn't work. That's what I've been trying to work on. The difference between this and double whatever, for example, is that they enforce very aggressive constraints on what you can and can't do. So, for example, if anyone's ever had the problem where you don't declare like a header file correctly in a make file, and then things don't get recompiled when you change things because you forget to include the dependency, for example. If desired, these build systems, for example, can actually explicitly, if you try and use something that you didn't ask for, they'll just fail, which is quite brutal. But then means that when things are actually checked in, people can actually rely on the assumptions made to build things and make inferences about the project. As a result of basically paying the price, we've bought an option to do things. There are questions we can ask and things we can now do which we couldn't previously do. So, for example, with regard to the point I made earlier about things eventually becoming slow because they're doing too much, they're just doing too much work. For example, in your CI and so on. If we have a static graph, we can ask questions of it in both directions. If you have a diff, you can work out exactly which things you definitely need to run. If you have enough information about the inputs and actually the outputs, then you can cache things. And the bullet point that's missing there is that you can send work off to a server to do it for you. So, for example, you can do like a parallel build with however many 1,000 jobs, if you so wish. So I've mentioned Buck and Bazel. There are already D rules for Bazel. So the reason why I'm effectively talking about it now, rather than saying just use Bazel, is that firstly, all of the other offerings are basically priced in, whereas Buck is sort of new and interesting because it has a slightly different theoretical model where they've integrated a mixture of sort of innovations from other build systems and relatively new academic research to be able to, it can actually deal with that like dynamic dependencies properly, for example. So you can be a lot more expressive in the input rules. And the specific, the thing that initially caught my interest is that the build system itself doesn't actually know anything about any of the languages which it like supports, in quotes. So they're all defined in a standard library of the Starlark stuff that I mentioned earlier. Some of which means that, in fairness, some of it is a little bit janky, but it means it's extremely flexible and it's very easy. It's very easy to just throw everything else away and go your own way, especially if, for example, you have existing stuff you want to onboard. Because one of the reasons why people don't use Bazel in particular is because it's basically a kind of like step function in terms of using it. And on a ergonomic front, Bazel is, I think, is at least partly written in Java, which some people blame for some of the performance problems, but I don't think that's actually true. But it just means that like rolling out to people can be somewhat difficult, whereas with Buck2, for example, it's just a static binary that you just download and run, and that's it. The way you add new things, i.e., for example, D rules and so on, you write your rules in effectively a sort of Turing incomplete subset of Python called Starlark, which looks quite bizarre, but it works. It's a fairly strange language that's evolved over time, but it's a standard and they're sticking with it. It means there's some level of compatibility between things. So there are some odd bits of software heritage where like the project is actually like kind of bits of it like pass in between sort of Google and Facebook and so on, where they've lost interest in some parts of the ecosystem. The key part is that we have to write basically everything that we want to do, and anything that the things we do could touch has to be declared. Either declared or we have to read in a dep file afterwards, so the build system knows and is able to actually store stuff properly. As I said earlier, there's good and bad to that. And on the one hand, obviously, you build a much greater set of assumptions about the work you're doing. But then obviously you actually have to write the stuff, which is quite annoying. There are escape hatches for doing things more efficiently. So for example, like you can quite happily build stuff without actually writing any rules because there are basically sort of generic escape hatches. But if you want to do things like properly, you have to sit down and write them. But that reminds me of something that David Ogilvy said about advertising, which is that sometimes the benefit of a sort of marketing campaign, and sort of especially sort of like sitting down with people who actually do it for a living, potentially similar with the kind of Ivy stuff that was going on last year, is that the benefit can sometimes actually be introspective, in that it forces you to actually like think about what your brand means. So there's still your brand and your values and so on as a company, and what you kind of want. So even if you paid them and then never actually use the ad campaign, you still gain something. And there's something similar with this kind of thing, where being forced to think about stuff, and indeed putting an upfront cost on some kinds of complexity might actually have a benefit. Although obviously you don't want to like deliberately block people, because you have to actually do work and get paid. The example that I've gone for to demonstrate Starlark is actually slightly left field, in that we're actually not going to build anything. I think everyone could basically work out how to do that. Read the docs and copy some examples. So I thought I'd demonstrate something that, for example, you can't really do sort of cleanly in a less expressive build system. So I went for actually running a code formatting check. Some things can sort of handle. So for example, I think Dub has dub lint, for example. I don't know if anyone actually uses it that much, but and like npm has like a scripts block you can use, but it's basically a complete Wild West chaos internally. But with a more powerful build system, you can actually just encode this just the same as the test that tests the behavior of the code, because it's effectively the same thing. It doesn't really care about what's going on underneath. And this is a tool chain for such a linter, where at the beginning of anything you want to do, you'll write a tool chain. So the user can actually, they have to say, for example, where a compiler comes from, whether it be the system or the internet or whatever. And one of the interesting things here is that if you see we have the URL and the SHA-256, this actually runs off and downloads the tool as part of setting up the tool chain, which, for example, means that if you were onboarding someone to a project, for example, as long as they have the build system, they can have all the tools, which I think is actually quite nice. The provider up at the top is effectively the equivalent of a struct. And then we return here. You then add this to your folder called toolchain, in which you can configure your toolchains. So that'll run off and download this particular formatter from a GitHub release, and then just sort of set it up. You don't have the kind of the classic problem with like a format check fails in CI, and then you don't actually have it locally at all. You don't have to like run away and replicate a CI environment on your machine manually. And then in terms of actually running the tool, we write a rule called biome check, in which the interesting bit is that we add an attribute to the rule called a toolchain dependency, which will then implicitly add whichever active toolchain, like go and look for it and grab it automatically, which we can then pull the binary out, and then we return a test info, which just runs a command called CI, which just does an immutable check on the file, which you then configure like so. It points to the JavaScript file, whatever. And then it just becomes another test where I'm calling it directly here. But for example, you can build, there's a query language where, for example, you can ask for any, you have a list of files and a diff. So then you ask for all of their like reverse dependencies going up the thing, and then you run all the tests. These would just appear along with those. Okay, so the image didn't get included in the PDF. If you imagine, you run test, it runs the tool, and then because I've made sure it fails and gives you an error message, et cetera, et cetera. I think this is fairly enticing for a certain type of project, but if you Google for declarative build systems, one of the top results is, not saying with a question, why aren't they popular, but telling us why they aren't popular, which is true. The incentives aren't there for a lot of projects. So for example, most open source code usually wants to be a cog in someone else's gearbox. And these don't make a huge amount of sense in that kind of situation. Similarly, pretty singularly aimed at monorepos, which I'm a fan of, but I'm not aware of. Sorry, not everyone else is. Small projects in particular, they're also just they can just get in the way. Like a shell script is fine. The reason why I'm actually bothering to talk about this and getting interested in it is all of these points are true with this. You all kind of particularly complicated build systems a lot of the time. But I think the way they've done Buck2 is a lot more malleable and interesting for a smaller project. So for example, I think it would be completely feasible for like something like Dub, for example, to actually like bundle Buck2 with it and then run it in the background. And because it's a static binary as well, it's also much easier to bootstrap it as part of a relatively simple kind of open source thing. I had a closing note, but I've forgotten what I wanted to say. Yeah, I think I'm at the end. So there you go.
There's another advantage to declarative build systems that I think is worth mentioning. So in systems like Blaze or Bazel, it'll stick around as a server. It'll keep running, and it'll basically remember build artifacts. So if you have many developers working on the same project, they can share pre-built artifacts and greatly improve the build speed of incremental development. That's a big advantage why they're often really liked in companies. And then an idea to an explore, because you mentioned like these rule-based build systems like Make, and then kind of the jump to these declarative systems. One intermediate step that's a bit smaller that might be worth also thinking about is, so in Java, it's quite old, but there's a build system called Maven. And what they often do is, rather than just having bare rules or a complete declarative system, they have an API with a lifecycle. And the lifecycle can have like pre-build, post-build, whatever. And when you write plugins, you can access that API. And so you can write a plugin that says, before you build the code, run this linting tool. And then because it has a built-in concept of a repository, you can have a repository for your packages and dependencies. And there's also a plugin repository. So I can say, give me this tool that runs a linter. So there's like two common ones, Surefire and Failsafe, which run like integration test and JUnit test. There's other ones for linters. And it's kind of like a much simpler way of getting access to this kind of functionality without a full commit to something like completely shifting over to a paradigm shift like a declarative system. So it's just an idea worth exploring. That's it.
Yeah. I mean, speaking of bridging the gap, I think one thing you can do particularly easily with Buck2 in particular is that you can declare rules that don't do anything and then capture who had an existing sort of loosely defined set of projects which may or may not depend on each other in a sort of big monorepo, for example. You can have rules that capture effectively like the gist of effectively the sort of the political structure of the project without actually having to build things by default, and then you get a lot of the benefits of the just, for example, like with querying things based on like files, for example. You get a lot of the benefit to begin with to kind of get people on board. Having a more complicated system without having to commit and break everything inevitably. To begin with, one thing I also completely forgot to say is that I mentioned the D rules in it at the moment are a stub, and I have most of them working, but the reason why they're not in the slides here is because they are the style in the sort of standard library kind of prelude is relatively advanced, so that they'd be quite confusing. Or rather, there's basically sort of historical baggage which you kind of like to get them merged in. You have to join in with before they undo it. Although it does move extremely quickly.
Towards the beginning of the talk, you had a slide where you mentioned that with static build rules, you can sort of capture the environment and then do global caching, like across the entire company. Mm-hmm. I've seen a bunch of people mentioning that sort of thing, and we're sort of experimenting where I'm sort of like trying it out right now at Funkwerk. And one issue I'm running into is that we have 100 megabit network mostly still. And like with the way D generates very large binaries very quickly, it at least isn't obvious that it's faster to get it from the network than to get it locally. Mm. And I'm kind of wondering, like, generally speaking, asking around, how do people resolve this? Do you all just have faster network than we do? Do you use compression? Like, what's the answer there?
One of the features that the sort of big boy build systems have is that they can completely defer the build entirely. So, for example, if it's cached, First of all, there is a heuristic where it will just build it locally, but don't ask me what, but it exists. But then they will just completely defer the build steps entirely if it can. So it won't by default, for example, like fetch a bunch of stuff and then just send the job straight back off to the server. Because the idea is that the remote execution model is the default, because one of the sort of it's, I wonder if it's entirely honest, because it sort of doesn't, but one of the taglines for Buck2 is that it's technically a remote only build system that just happens to build locally.
So if I understand you correctly, the gap here is that what I'm thinking of in terms of a build system is something that makes artifacts appear on my computer in a folder. And what Buck thinks of it as a build system is just something that runs tasks somewhere. Is that about correct?
Yes.
That makes sense. Thanks.
I have been trying Buck2 actually as a proof of concept to replace or actually trying to build faster with our code base. And did you actually try to do a prelude for D?
Pardon?
A prelude for D? Like there is an official prelude.
Yeah, I have like basically a commit on my personal machine, which I've been like tinkering around with, and it's almost there, especially if you have a project which the tricky bit with compiling any D code is always going to be like the dub dependencies. But for example, within a kind of relatively closed system, it's actually not like D is reasonably sensible. Actually, the one blocker I had actually was that by the server we currently host the DMD releases on doesn't respond to a HTTP head properly. Like as they demonstrated that you can I wanted to download the toolchain or be able to download a toolchain.
Yeah.
For the purposes being for testing and so on, very especially. I couldn't actually get that working with DMD, but like there's enough there to know that doesn't work. So when I get a chance, probably like next weekend, I'm going to try and actually upstream. I actually don't know how they have actually added support for external rules, which you'll fetch from a Git repo. Now, but I think the best way, especially kind of cynically as a marketing tool for D, is to have them in the main sort of prelude.
Yeah. I made a prelude, so if you want to share things, you can, yeah. And one thing to answer the other person, there is also one cool thing about Buck that you can add heuristics to the rules. So for example, you can say that one rule is more expensive than another. So for example, some builds are deferred to the remote machine, and some that is very cheap can be done on the local machine. So yeah, that's also pretty cool.
Yep.
I was wondering, have you considered Nix as well as a build system? I know it's a bit different, but we're using Nix actually in our repo. We also use mono repo, but we're actually able to run tests with it. You can even set up a caching server as well. And I think like that's basically made for open source in the sense that I think it's actually the biggest package repo now, like the Nix package repo. So lots of packages are actually working with it, and even Dup is now actually supported with Nix, which is quite nice.
I'm not particularly good at Nix, but like I generated this PDF using a Nix package.
Yeah. Okay.
So like I'm a believer. But the only thing I say is that I think Nix is a fairly crap build system. Like it's not really. They do actually in the build system that a la carte paper, they do actually also build a theoretical model of Nix, which is quite interesting. But the way I would envisage it sort of mentally is more that you have Nix to provide, for example, maybe the tools, and then a build system which you may then package as inside a Flake, for example, or whatever. And one thing you can do, which is quite interesting, there's a guy called Thought Police on GitHub who has a project called like Buck2 Nix, which is like an entirely custom set of build rules where all of the, I think like there's something similar for Bazel as well, where when you set up a tool chain, what you're actually doing is it builds a Nix environment in the background. So as long as you have a machine with Nix, I don't know how it works with. Other that being said, I think there are some blockers with the like remote execution for that. So it's not it's not completely a free lunch, but it can be done, and there are people quite interested in it. Yeah.
I have a question about whether it would be useful to take the model, the semantics of a functional programming language and extend it to operate not on values in RAM, but also on values referenced via hash digests of any data fetchable from any place. In that, if you had that, you could basically treat that as a build system operating on files and files accessible on GitHub and so on, and add a layer of caching somewhere where you think it's performant.
Yes.
Have you thought about that?
I mean, not really in this context, but it sounds a bit like Urbit. If you're familiar with the Urbit project, but
What is the project?
Urbit.
Okay.
So it's a fairly strange. But I'll talk about it later.
So why aren't Buck so would it be useful for an organization like, or a company like Symmetry to use something like that? What are the benefits?
Why? What do you mean? Do you mean what I'm talking about, or what you just mentioned?
I'm just looking from the perspective of Buck2. What are there any obvious pros about using Buck2 instead of such a functional programming language with caching?
Well, I mean, obvious things first. One of them exists, but I think the underlying model of Nix might be quite similar to that, but I don't know. Like I don't have a particularly clear opinion. So you can speak later.
Yeah, just wanted to say, if you look at Nix, it's pretty much a pure language that you can declaratively define your build. It's sort of what you mentioned, but yeah, not fully. But it basically hashes everything, and it's pretty much a build system that it's functional.
I think that's it, though. Yeah. All right. Thank you.